So guys, we are starting with exercise 19A of differentiation chapter, and in this particular exercise we have to solve the derivative of the function or differentiate function only using the first principle. Okay, now when they say using first principle, then only apply this method, otherwise please do not apply this method. Okay, solve it normally using derivatives. Fine. So let us understand the first principle with some examples given in the textbook. So y is equal to given 2x. So instead of writing y, I write f of x. F of x is equal to 2x. Y is technically f of x. This is given to us. They're asking differentiate using the first principle. So this is step number one, the given statement you have to write. Then always write down x plus h, f of x plus h. Replace x with x plus h. Wherever there is x, put x plus h. So this will be 2x plus 2h. So now using first principle, f dash x is equal to limit h approaching 0, f of x plus h minus f of x upon h. Now this formula of using limits, this is called as derivative using the first principle. F dash x is the derivative. Technically, what is f dash x? F dash x is dy by dx. Okay, right? So using limits, this is the first principle. So f dash x is equal to limit h approaching 0. Now both the values we do have. Okay, f of x is the question itself. F of x plus h we calculated. So put those values. So f of x plus h is 2x plus 2h. F of x is 2x upon h. So 2x and 2x will get cancelled. Limit h approaching 0. 2h upon h will get cancelled. Limit of a constant is constant. So the answer is 2. Fine. Let me take you to the next problem. Question number 2. F of x is equal to x minus 1 the whole square. Find out f of x plus h. So replace this x with x plus h. Okay, right? So using first principle, f dash x is equal to limit h approaching 0, f of x plus h minus f of x upon h. Put the respective values. So f of x plus h is x plus h minus 1 the whole square. F of x is x minus 1 the whole square. Okay, upon h. Now in the numerator we can apply a square minus b square, that is a plus b into a minus b. So x plus h minus 1 is a, x minus 1 is b. So I'll write the next step. F dash x limit h approaching 0. So a plus b, this value plus this value. So x plus h minus 1 plus x minus 1 into x plus h minus 1 minus x minus 1 upon h. So limit x approaching 0, x plus h minus 1 and just open the round brackets, plus x minus 1. This is the first box bracket. X plus h minus 1 minus x plus 1. This is the second box bracket. So here x is getting cancelled, and then minus 1 plus 1 is also getting cancelled, right? So we are left with h in the second box. So x plus x is 2x plus h minus 2 upon into h upon h. So h will also get cancelled. H will also get cancelled now. Now put the value of h as 0. So this will be 2x plus 0 minus 2. So this will be 2x minus 2. That is the answer. f dash x. F dash x is the derivative of f of x. Let's go to the third problem. Question number 3. F of x is equal to x cube as per the methodology. What is f of x plus h? F of x plus h will be x plus h the whole cube. Okay, so now using first principle, f dash x is equal to limit h approaching 0, f of x plus h minus f of x upon h. So limit h approaching 0, f of x plus h is x plus h the whole cube minus x cube upon h. So if you know the formula of a cube, there are two ways to solve this. Either you can do a plus b the whole cube, or entirely you can do a cube minus b. So a cube minus b cube is a minus b, a square plus b square plus ab. So I'll do a cube minus b cube. So a minus b, a square plus b square plus ab. Okay, plus ab. Fine. See, a is x plus h and b is x. So x is gone. We are left with h. So this h and this h will get cancelled out. Okay. And then you can put the value of h as 0. Put the value of h as 0. So this eventually will be x plus 0 the whole square, because there is no denominator now, plus x square plus x plus 0 into x. So this will be x square plus x square plus x square, which is equal to 3x square. That is the answer for the third problem, right? So let us go to the fourth problem. Yeah. Fourth question, f of x is equal to 1 upon root of x. F of x plus h is equal to 1 upon root of x plus h. Replace x with x plus h. Using first principle, f dash x is equal to limit h approaching 0, f of x minus f of x, x plus h minus f of x upon h. So limit h approaching 0, f of x plus h is 1 upon root x plus h minus 1 upon root x divided by h. Why divided by h? This h is written as divided by h over. In the box bracket, you can take LCM, limit h approaching 0, and this will be root x plus h into root x into 1 upon h. Okay. Now, whenever we have a situation of root minus root, then we rationalize numerator as well as denominator. Rationalize the term wherever it is. It's in the numerator, so we'll rationalize the numerator. Okay. So this can be written as limit h approaching 0, root x minus root x plus h. So just rationalize this. And already there are three terms left in the denominator. I'll take you to the previous slide and show. The three terms are root x plus h, root x and h. So I just write those three terms. Limit h approaching 0. In the numerator, we are going to do a square minus b square, because it is a minus b into a plus b. Denominator will remain the same. Okay. Now cancel this x, and then we are left with plus h in the numerator. So this is written as equal to limit h approaching 0 plus h in the numerator, root x plus h, root x, h, and then root x plus root x plus h. Now h is also getting cancelled. Okay. Now we can put the value of x as 0, h as 0, because when you put h as 0 in the denominator, now it will not be entirely 0. Okay. So root x into root x is x, and root x plus root x is 2 root x. So 1 upon 2 x root x. That is the answer. Okay. So I guess that was your question number 4. We take you to question number 5. Question number 5, f of x is equal to root x plus 1. F of x plus h will be root of x plus h plus 1 using first principle. Limit f dash x is equal to limit h approaching 0 f of x plus h minus f of x upon h. So limit h approaching 0 x plus h plus 1 minus root x plus 1 upon h. Okay, so now we have root minus root in the numerator. So just rationalize this. Rationalize, don't make any silly mistakes. Now in the numerator we are having a minus b a plus b, which is a square minus b square. A square minus b square upon h into root of x plus 1 plus root of x plus h plus 1. Just go back to the previous slide and check. X plus h plus 1 plus root x plus 1. Okay, now just open the bracket in the numerator. X plus h plus 1 minus x minus 1. The minus will be given to both. First of all, the root and square is getting cancelled. So we are left with h. Okay, now plus 1 minus 1 is getting cancelled. Plus x minus x is getting cancelled. So we are left with h. So this h and this h is also getting cancelled. So we are left with 1 in the numerator. So put the value of h as 0 in the denominator because it will not impact the denominator. One upon 2 root x plus 1. Fine. So that was question number 5. Let us go to question number 6. Okay. F of x is equal to 2x plus 3 upon 3x plus 2. So x plus h will be 2 into x plus h plus 3, 3 into x plus h plus 2. So 2x plus 2h plus 3, 3x plus 3h plus 2. Okay, so f dash x will be limit h approaching 0 f of x plus h minus f of x upon h. So this is equal to f dash x is equal to limit h approaching 0. Now f of x plus h, this entire term, 2x plus 2h plus 3, 3x plus 3h plus 2 minus f of x. F of x is 2x plus 3 upon 3x plus 2. 3x plus 2. Okay. Divided by h. Divided by h. There are too many fractions, so I'm doing this. So this h, I'm writing it as divided by h. So limit h approaching 0, 2x plus 2h plus 3, 3x plus 2 minus 2x plus 3, 3x plus 3h plus 2. The whole upon 3x plus 3h plus 2 into 3x plus 2 into 1 upon h. This h is written as 1 upon h. Now we have to very clearly open these brackets because otherwise it will be very difficult if you don't do systematically. So limit h approaching 0. So 3x into this entire term, 3x, 2x plus 2h plus 3, okay, plus 2 into the entire term. So plus 2 into 2x plus 2h plus 3 minus this 3x, sorry, this 2x into the entire term, but then there is minus sign outside. So minus 2x, 3x plus 3h plus 2. Okay. Now minus into plus is minus, minus 3. 3x plus 3h plus 2 upon these three terms. 3x plus 3h plus 2. Okay. Into 3x plus 2. So limit h approaching 0, 6x square, 6 hx plus 9x plus 4x plus 4h plus 6 minus 6x square minus 6hx minus 4x minus 9x minus 9h, okay, minus 6 upon 3x plus 3h plus 2, 3x plus 2 into h. Now there are many cancellations, okay, so just be ready for this. There will be cancellations. So 9 minus 9 plus 4 is minus 5. So this equal to limit h approaching 0 minus 5h. This h and this h will get cancelled, but then the other two denominators are 3x plus 3h plus 2 into 3x plus 2 into 3x plus 2. So this will be, see, now we can put the value of h as 0 because it won't impact the denominator. So put h as 0, so this will be 3x plus 2 and this also will be 3x plus 2. So minus 5 upon 3x plus 2 the whole square. Fine. So that was your question number 6. Let us go to question number 7. Let us go to question number 7. f of x is equal to 1 upon root x plus a is a constant, f of x plus h 1 upon root of x plus h plus a. So using first principle, f dash x is equal to limit h approaching 0, f of x plus h minus f of x upon h. This is also limit h approaching 0, f of x plus h is 1 upon root x plus h plus a, okay, minus 1 upon root x plus a divided by h, divided by h. Fine. So to take a look at this further, you have to take LCM, limit h approaching 0, root of x plus a minus root of x plus h plus root of x plus a minus root of x plus h plus a upon these two terms, root of x plus h plus a into root of x plus a. And that division by h, I'm writing it as into 1 upon h. Okay. So what you have to do is, we have got root minus root in the numerator, this part. So this part will be rationalized. Okay. So root of x plus a plus root of x plus h plus a. Root of x plus h plus a, root of x plus a into h. These three terms will be written over here. Fine. Now in the numerator we are having a square minus b square. Denominator there are four terms. Okay. Now cancel out the root and square. So limit h approaching 0, x plus a minus x plus h plus upon root of x plus h plus a, root of x plus a, h, and these two terms with a plus sign in between. Okay. So see, this x and x will go, this a minus a will go. So we will be left with minus h in the numerator, minus h in the numerator. Okay. So that h will get cancelled now. Now if you put h as 0 in the denominator, entire denominator won't be 0. So put h as 0 in the denominator. Wherever there is h, put 0. Okay, so root x plus a into root x plus a is x plus a into root x plus a plus root x plus is 2 root x plus. This becomes your final answer. Okay, you can arrange these terms in the denominator, but then this becomes your final answer. This is question number 7. Now let us go to question number 8. F of x is equal to x plus 1 upon x. So we'll take LCM, x square plus 1 upon x. So this becomes question number 12. So while solving 12, there is no need to solve question number 12 from my end, because This itself is question number 2. So 8 and 12 are technically same. F of x plus h. So wherever there is h, x, write x plus h. We just simplify the numerator. Okay. Now f dash x is equal to limit h approaching 0, f of x plus h minus f of x upon h. Okay. So f dash x, let's put the value of f of x plus h. F of x plus h is this, x square plus h square, x square plus h square plus 2hx plus 1 upon x plus h. Okay. Minus x square plus 1 upon x divided by h. Okay. So limit h approaching 0, take LCM, x square plus h square plus 2hx plus 1 minus x square plus 1 into x plus h. Okay. X plus h into x. Okay. The whole divided by h. This box bracket divided by h. So limit h approaching 0, x cube plus xh square plus 2hx square, xh square I'll just write it as h square h square x in the alphabetical order plus x. Now minus x square into x is minus x cube, minus x square into h is minus hx square. Okay. Similarly, the plus into minus, this minus into this plus will be minus. So minus 1 into x is minus x, and minus 1 into h, this h, minus 1 into this h will be minus h. Okay. So this will be into 1 upon h, division became multiplication, and down it will be x plus h into x. X cube and x cube is gone, x is gone. Okay. So now if you take a good look at this, right, one more term is left to be cancelled, h square x, h square x is gone. So only 2hx square minus h, this term is left in the numerator. So this equal to limit h approaching 0, okay, 2h square, 2hx square minus h, 2hx square minus h upon x plus h into x into h. Take h common in the numerator, 2x square minus 1, x plus h into h, right? So see this, x plus h into x into h. So h is gone, put the value of h as 0. So this will be 2x square upon x square. Fine. So this is what the solution is for this particular problem. Okay. Just let me take a look because there were many terms and should not go wrong anywhere. Yeah, so this is x into x, which is equal to 2x. Fine. One second. X into x will be x square. Sorry. I'm just getting this additional 2. I'm just checking for that. We'll go back to the previous slides. 2h square, 2h x square minus h. So I probably went wrong over here. So I'll just cancel out this cancellations and redo this. Okay. So see, x cube and x cube is gone, minus x cube, this is gone, right? Then this x and this x is gone. So h square x is one of the term. Now 2hx square minus hx square is hx square. So by mistake I had cancelled that. So I'll just redo this. So limit h approaching towards 0, h square x plus, okay, 2h x square minus hx square is hx square minus h. Why minus h? Because there is minus h over here. Okay, upon x plus h into h into sorry, into x into h. Okay, now limit h approaching 0. We'll take h common in the numerator. So hx plus x square minus 1 upon x plus h into x into h. So this h and this h is getting cancelled. Now you can put the value of h as 0. So 0 into x plus x square minus 1 upon x plus 0 into x. So this is equal to x square minus 1 upon x square. This is the final answer. Okay, so I made the mistake in cancelling, but then I have re-explained to all of you. Fine. That was your question number 8 as well as question number 12. Okay, let us proceed with the next question. That is question number 9. Fine. So question number 9, f of x is equal to root of 2x plus 3. F of x plus h is equal to root of 2 into x plus h plus 3. So root of 2x plus 2h plus 3. F dash x using first principle. Limit h approaching 0. F of x plus h minus f of x upon h. So this will be limit h approaching 0. 2x plus 2h plus 3 minus root of 2x plus 3 upon h. Now we have root minus root in the numerator. We have root minus root numerator. To just rationalize this, you'll get the answer. Okay, I won't solve this, but then I have given you the hint. Okay, now let us go to question number 11. Fine. So f of x is equal to x plus 1 into 2x minus 3. Let's multiply these terms. 2x square minus 3x plus. So 2x square minus x minus 3. So f of x plus h will be 2 into x plus h the whole square minus x plus h minus 3. Fine. So this will be 2 into x square plus 2hx plus h square minus x minus h minus 3. So 2x square plus 4hx plus 2h square minus x minus h minus 3. 2x square will remain as it is. Okay. Any other cancellations are happening? Uh, I don't think so. So this will be the same. No cancellation is happening for you. Fine. Yeah. So now using first principle, f dash x is equal to limit h approaching 0 f of x plus h minus f of x upon h. Limit h approaching 0. Okay. So 2x square plus 2hx plus 2h square minus x minus h minus minus f of x. F of x is 2x square minus x minus. I'm just putting bracket because there is minus sign in between. Okay. Upon h. So see 2x square and 2x square will go. Minus x and plus x will go. Minus 3 and plus 3 will go. So we are left with 2hx plus h square minus h. So this can be written as limit h approaching 0 2hx plus h square minus h upon h. So take h common 2x plus h minus 1 upon h. Now put the value of h as 0. So the final answer that you will get is 2x minus 1. Final answer that you will get is 2x minus 1. Okay. 1 second. So this is 4hx. Okay, this is 4hx. Sorry. So this is going to be 4. This is going to be 4. This is going to be 4. So I just made a copy error. Fine. So make it 4 everywhere. Okay. So the answer is 4x minus 1. Question number 10. Let us focus on question number 10. Fine. So the question is 1 upon x raised to 3 by 2. Now x raised to 3 by 2 can be written as x root x. First thing that you need to know is x raised to 3 by 2 is x root x. See x raised to 1 into x raised to half. So that is x raised to 1 plus half, which is x raised to 3 by 2. So x raised to 3 by 2 is x root x. So f of x, question number 10, f of x is equal to x raised 1 upon x raised to 3 by 2. Okay, so f of x plus h will be 1 upon x plus h raised to 3 by 2. Okay, so that is 1 upon x root x, and this will be 1 upon x plus h root x plus h. F dash x as per first principle, limit h approaching 0, f of x plus h minus f of x upon h. So limit h approaching 0, 1 upon x plus h root x plus h Okay, minus 1 upon x root x divided by h. This h is this division by h. So you have to take LCM over here. Limit h approaching 0, x root x minus x plus h root x plus h, x plus h root x plus h, x into root x into 1 upon h. Now again we have root minus root, something of that category, root minus in the numerator. So x root x minus x plus h root x plus h, x root x plus, okay, I'm rationalizing the numerator. So this is x plus h. See, it's not difficult. You have to keep a presence of mind and avoid some silly mistakes. Okay, so this is a minus b into a plus b. So a square minus b square, a square minus b square. Down it will be x plus h, root x plus h, x root x, h, then x root x plus x plus h, root x plus h. Fine. So this will be x square into x square into x minus x plus h the whole square into x plus h upon root x plus h into root x. It's a big term in the denominator. Into, sorry, x plus h into root x plus h, x root x into h, x root x plus x plus h, root x plus h. Okay, the last box bracket. Limit h approaching 0, x cube minus x plus h the whole cube, x plus h, root x plus h, x root x, h, x root x plus x plus h root x plus h. You can do a cube minus b cube in the numerator, or you can just simplify this as a plus b the whole cube. I'll do a plus b the whole cube. A cube plus 3a square b, 3ab square plus b cube upon x plus h root x plus h. This is a very big term and quite boring as well to write this again and again. Okay. So this x cube and x cube is getting cancelled. We are left with these three terms, but then these three terms are negative because there is a minus sign outside. Okay, so you take h common. So outside when h goes, it will be minus h because there is already a minus sign outside. Minus h into 3x square plus 3hx plus h square. 3x square plus 3hx plus h square upon the bigger term x plus h root x plus h, x root x h, x root x plus h into root x plus h. Okay, now finally one h is getting cancelled. Now put the value of h as 0. So minus 3x square plus 3 into 0 into x plus 0 square, x into 0 root of x plus 0 into x root x plus 0 root of x plus 0. So minus 3x square, okay, this x into this x is x square, fine, and root x into root x is x. Now this is x root x and this is also x root x. X root x plus x root x is 2x root x, fine. So what happens is this x square and x square will go and the final answer will be minus 3 upon 2x square root x, fine. So it's a very complicated question, fine. But then you can stop it over here. You need not simplify this further by taking indices and not required. Okay, so that completes this differentiation using first principle. Okay, thank you.